Hi everybody, today's topic is scientific notation. You do not need to write down everything in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember that you can pause the video to jot down important notes, rewind the video to view information again, and fast forward if you think you got it. Just be careful and make sure you don't fast forward too much that you miss out on something important. So let's begin. 5 times 10 to the 4th power actually has a special name. It is called scientific notation. It is a shorthand way of writing incredibly big or incredibly small numbers by using the powers of 10, used by, of course, scientists. Really big numbers, we said it was like world populations. Really small numbers would be like measuring something for a bacteria or an amoeba or a virus, something like that. So what's in red here, 5 times 10 to the 4th power, is an example of scientific notation. So scientific notation follows this structure. It's a number between 1 and 10, so it is usually just one digit, times an integer power of 10. So here are some examples of scientific notation numbers. We have 5.2 times 10 to the 3rd power. So instead of writing 5,200, you can write 5.2 times 10 to the 3rd power. That means that the decimal point is between 5 and 2, and we're moving it over 1, 2, 3 decimal places to the right to get 5,200. Instead of writing this huge number, we can write 8 times 10 to the 9th power. And then someone would say, okay, if the decimal point was originally after the 8, I'm really moving it over 9 places, or 9 zeros, to get my number. So instead of writing this huge number, I can just write the shorthand, 8 times 10 to the 9th power. And if there were even more digits behind that, then I'd be saving a whole lot of time. This one right here is a negative exponent, so it's a really small number, 4.391 times 10 to the negative 2nd power. So the decimal point is between 4 and 3, 4.391, and we're now moving it 2 spots to the left, 1 and 2, and that's how we got 4.391 times 10 to the negative 2nd power. So that's scientific notation right there for you. Okay. Let's go over some examples. Here is an example from scientific notation. Express this number in standard form. So they want you to write it out without the scientific notation, with the commas. So go ahead and pause this video, see if you can try it on your own. All right, so we have 3.643. It was multiplied by 10 to the negative 1st power. Negative power means it's becoming an even smaller number. So we got to move it 1 spot to the left so that it becomes an even smaller decimal. If we move it 1 spot to the left, we end up with the decimal point over here. So we have 0.3643 as our answer. So the power just tells us how many places to go and in what direction. We were going to the left because it's becoming a smaller number, and we only went 1 decimal place. Let's try another one. Express this number in scientific notation. Pause the video and try it on your own. Okay, this one is 52 thousandths. So if we were to write 52 thousandths, we kind of need to know our place value names. So this right here is the tenths. This right here is the hundredths. And this right here is the thousandths. So what does that mean, 52 thousandths? That means I need to put the 52 in the thousandths place. And then I can fill in that 0 here. This is 52 thousandths. Without the 2 over here, if I scooched it over here, without the 0, it would be 52 hundredths. So we want to make sure it reaches the thousandths place. Now they want us to write it in scientific notation. So in scientific notation, I need to make sure that I am counting how many times this decimal place is moving over so that it is still a number between 0 and 10. So if I move it over once, it's just 0.52. That's not good. Move it over twice, I get 5.2. That's good. That's a number between 0 and 10. So it becomes 5.2 times 10 to the, this is 2 spots, and it's a decimal, so it's negative. 5.2 times 10 to the negative second power. If I moved it over another spot, it would become 52. Remember, we want a number that's between 0 and 10. So this is 5.2 times this sign right here, 10 to the negative second power. Okay, let's do another one. This one right here is in scientific notation, or it's in standard form. We need to change it into scientific notation. Pause the video and try it on your own first. All right, let me magnify this so I can see it better. I need a number between 0 and 10, so that's where I need to stop. 1, 2, 3. Still not a number between 0 and 10. And another one, that'll give us 2.077. That's a number between 0 and 10. That's how I know to stop. I'll stop right after the first non-zero digit. And then I need to multiply by 10 to a power. How many powers, how many place values did I go? 1, 2, 3, 4. And is it positive or negative? This is a very small number, so it's going to be negative. So your answer should be 2.077 times 10 to the negative 4th power. Okay, so we move that decimal point over all the way until we get to a number that's between 0 and 10. That was right after 2 would have been 2.077. And then we count how many, 1, 2, 3, 4. And it was a really small number, so it's a negative. Let me know if you have questions as you're working on these. I'll be more than happy to answer them. And if not, I will see you in class.